we're starting back up again. The problem I had with the source code example that I was looking at last time was user error, actually. It was user error because I failed to import the correct, I failed to actually include student.h in my source code. So let me show you real quick. But before I do that, I want to show you what happens after you create the project. So I've unloaded Xcode, actually. And I have this folder, and remember it was called First Project, and I saved it to my desktop. So if I double click on the folder, it opens up. And this is how I load this project again. I can just double click on the project file. This is the Xcode project file. And it loads back up into Xcode for me. And this is the line of code that I left off. And that line of code, because I didn't include it, none of this stuff would work. I also took out the auto release pool. It seems like we don't need it anymore. Some of the stuff with the newer version has been automated. We don't have as many options on the project. And we'll see later when I load up another project. All my projects are saved in older file formats and older project formats. I have been on at the lunch break here. I've been updating my Xcode to include the lower, this 5 point. This is 7 point. This is iOS 7. So I put the 6 support and the 5 support on here so I can go back to what I'm familiar with. Because I actually haven't really played around with 7 yet, but apparently the UI components are a bit different. So, unless some of you have played around with iOS 7, which I don't think is out yet. Maybe it's out today. I'm not sure. But anyway, long story short, this was the line of code that I needed to put in. So let me finish this example, then I'll go back to the lecture. Then I'll go back to more concepts. But before I do that, I want to show you another technique as well. So the project is out here. If I move the project around, I might actually be able to locate it again by opening up Xcode and bringing it in this way. If the project is still in its original location, then I can just click on it here. Checking out existing project, this is a brand new feature actually, and this would be for online repositories, which I'm not going to do actually. So instead, this is the same thing we used to have in the older interface as well. It just looks a little bit different. I could still click on the project this way and load it up this way if I wanted to. And I can also clear that menu out actually if I come back in here, open this up, go into File, and then on Open Recent I can clear the menu. So then when I go back in again, it's gone. No recent projects because this is going to get cluttered up as soon as you start making sample after sample. So what I normally do is I just load on a project file and load it up this way. So this is the code. What I did is I cut and pasted the main code that I had in the example in the code1 zip file, and I stuck it in this main. So we still, just refresh your memory because I know it wasn't that long ago, but we still have the interface file for students. It doesn't really matter. We don't have to import anything or include anything on the interface. And then we have the implementation file. And the implementation we had to include student.h. And then the part that I was failing to remember was this part here where we have to include it in the main as well. So it's kind of very similar to C++ where we include the file so we can make an instance of it. So let's take a look at making an instance of it. As I mentioned before, everything in the language is dynamic and it does use pointers. So here we have a reference that's created. So this is actually a pointer reference, not really a pointer. What is a pointer? Where we have student, and if you took C++ and you didn't like, or C, and you didn't like pointers, you're no luck here. You have pointers all over again. So pointers, you can't get around it. That's how we do the dynamic behavior. So student is the name of our object. We use this asterisk to say that it's a pointer. And we're going to call the reference to this object an iOS student. So he's an iOS student, which is going to be the name of the student. So when we create a student, we actually have 3 steps. We don't have any new. So if we were doing this in C++, it would look very similar. This line would be identical, actually. And then in C++, we would go iOS student is equal to new student. We'd actually allocate, whoops, we don't have to do that. We could actually allocate a student. And we can go here and go, oh, we don't, this is going to tell us that we haven't allocated it yet. It says replace iOS student with, yes, that's a typo. whoops, there we go. It's taking C++ code naturally because it works. So anyway, you don't want to do it this way. This is the C++ way of doing it. Or some people did this in C++. They went students, I-O-S, if I spell it correctly. I-O-S, student. Oh, I already had that. Get rid of this guy up here. Anyway, long story short, I've already got it defined up here, but it's student IO students equal to new students, which is the same way of doing it. What we're looking at is an allocation and an initialization and a reference. So we're not doing C++, so I'll take that away. So here we have 2 lines of code that we have to add. So there's no new. New and delete don't exist. Actually, delete doesn't exist at all, but new, there's an equivalent to it. We alloc. So for those people who remember C with dealloc and alloc, it's the same thing. This is where it's coming from. Alloc allocates memory. So we have a student, and then we have, this is interesting because this is the syntax of running a method call. So what we're really running it on is the object of student. So this is equivalent to saying new student in C++. So that would be new student. And what it is a student then run alloc. Alloc is a method that says allocate, reserve enough space for a student object. And then once we allocate it, we initialize it. In C++, we have this thing called a constructor, and the constructor automatically gets fired for us, so we only have 1 line of code. We go new student. In Objective-C, we don't actually have an instructor. We call the initializer. We say which initializer we want. So we explicitly call the initializer. We can have many different initializers. And the initializer that we select, this is the default in it. And notice over here, I didn't create any initializers. In next coming lectures, we'll be creating initializers. Probably not this, well, maybe this weekend, who knows. But we inherited the initialize init from NSObject, so it's already there. So out here, there's a couple of different ways of doing this, actually.
What is the integer size? It's 4 bytes.
I'm sorry?
What is the integer size?
Oh, this is an int. This is not integer.
No,
This is init.
The student is an interface, right? When you do an alloc, how much memory is allocated at that point?
The memory that's been allocated is going to be something of size that would hold a student. I don't know exactly how much that would be. It would depend on the runtime environment.
Okay.
What we're doing is allocating a student.
Yeah.
And then we initialize the student.
2 integer objects, 2 integers, right?
I'm sorry?
That student interface has 2 integer variables defined in it.
The student interface has
Two
two data members, and it has 3 member functions.
It will be the size of that variables.
No, it should be bigger, because it needs to store this information as well. It needs to store enough space to do this operation and this operation, as well as store the data. So the space that's allocated for an object is the space needed to store everything about the object. So it would be more than just the data members, it would also be the member functions as well. Plus there's a little extra space in there just for, slack. So exactly how much space is reserved? I couldn't answer that question for you. It depends on the implementation. We just say alloc. We can't determine. When we do this, we can't pick how much space we want either. It just allocates it. But it's the same thing as when we go new student. How do we know how much space is going to be allocated if we were doing this in C++?
In C++, I'll have a structure. I'll define the structure of a student to contain...
Structure is different though. Structure is not an object. If you create a structure, then you're going to get enough space for each one of the data members of the structure. And you add up whatever you have, 2 integers, a float, or whatever you have in there. That's how much memory is reserved. That's an object. So it's not going to have the same data requirements. It's not like saying 1 integer takes up this space, 1 float takes up that space. With objects, we have more of a dynamic behavior that's going on. So we have methods and we have the data as well. So we have object space that's not calculatable. And all objects take up a different amount of space depending upon what's inside of them. But yeah, no, with a structure it's totally different. With a structure you can count it up. But that's not a structure. Let's see.
So when would be when the dynamic part of this come into picture? Space
When we run it.
So what is the dynamic behavior?
The dynamic behavior is that we're going to have enough space in the runtime engine for the object to be created, and then we're going to go to that memory location and we're going to initialize it, and then we're going to do whatever we need to do with it. The running of the program looks like just any other C++ program. There's no nothing different from a running perspective, from a user's point of view. The difference is going to be in the way that the language is implemented and what happens. Like, if we don't have any space, the garbage collector will come in and make space for us, hopefully. Otherwise, we're going to run out of memory. In C++, we don't have a garbage collector, but we already know when we compile it. This is easier to compile because we already know ahead of time if we're going to have enough space. We're not going to have any problems. But in a C++ program, it's going to test to see if we have enough space, and it's going to do checks on the data types and everything to make sure everything's good before it runs. So it's just a different nature behind the scenes. Nothing that the user or the programmer is going to see in differences. All right, so this is the super class initializer. It's INIT. We can put them together, and this is how they're put together here, actually, in this next line of code. So what we have here are two different objects that are created. This one, and I'm going to put the spaces back in this way. These three lines belong together. This is the object reference, and the reference is assigned a new alloc, a new student, and we initialized a new student. An iOS student actually got initialized, which is equivalent to going new student and then the constructor running automatically. So it's, same thing as accomplished, different lines of code. Here's different. Here's an allocation and initialization all in one using this ID I talked about. So we're not actually saying that this is a student, but we're allocating it with a student. So what we did was we took this alloc student and we put this inside of this. So instead of repeating iOS student, well, it's already the same student. We just take and we nest it. So you can see here the nesting where this piece, allocating a student, is initialized. You'll see it this way more often. Fewer lines of code, easier to look at. You'll see it this way more often using an ID. How do you know what you want? You're going to do a student, you're going to do a person, you're going to do another type of object. This is more generic in terms of and reusable, in terms of memorizing something. So if you're going to memorize it, probably not going to memorize it anyway. Or you could just use the explicit. There's no pros and cons here, except for this student. This, let's just do it this way here, because this is 2 lines of code because of the semicolon. This could be anything. It doesn't have to be a student. This has to be a student. So this references to a student. This one's to an ID. It can be anything. So we could have my faculty, my students, my staff, my employees, anything you want. Just keep that in mind. That's why you'll see this more often. You see this with iOS development all the time as well. So you can apply a method to an instance. And so remember we had those two instances, we had those two messages or methods that were in here. Let me refresh your memory on that. We have one that says set undergrads, the other one says set postgrads. And so in here we can run iOS student, which is the name of our object reference. And we don't use this my student. Oh yeah, we are using my student, that's good. Set undergrad colon gives it 120. And then we have a postgrad colon 2000. Just refresh your memory, that's equivalent to doing this, but we're not going to do this. Set undergrads. If I were writing it in C++, and if I spelled it all correctly, it would look like that. But we don't use the dot notation. In fact, this is going to tell me something about dot notation. No, it's going to say property undergrad, probably because I spelled it wrong. So, yeah, not found. Yeah, whatever. Anyway, long story short, what you're looking at is this dot here, and you're looking at the parameter in here. you have to do it this way in order to do it in Objective-C. So it's just a different syntax. This is the name of the object and the message we're sending to it. We're sending it with a parameter, so we use the colon, and the number that we're going to use in the parameters is the number here. And then we have iOS student print, my student print. That's because in here we have a print method. And the print method that we have is printing out total number of students, which is going to be the undergrads plus the grads. So it's taking those two numbers and adding them together. This is like doing a summation. If I run it, I will notice down here on the bottom of the screen, I've got the two print methods. And let's see if I can make this bigger. Oh, I can. Look at that. Perfect. That's what I wanted. I guess I could put some line returns in there, but I got total students in iOS is equal to this one, and then we have total students in iOS program is equal to 0 because we didn't assign any to this guy. So in main, I'm printing out my students, but I didn't give my students anything because I didn't initialize them to anything. So I have another example where it's just going to actually implement an initialization. In Objective-C, just like in Java, if you don't initialize a variable, like none of those two integers were initialized for this guy here, if you don't do it, you automatically get the default value for the variable. If it's an integer, it's 0. If it's a string, it's an empty string. If it's character, it's an empty character. You don't get that with C++, but you get that in Java, but you don't get that in C++. And you get that in Objective-C. So that's nice. So it's very... It'll initialize it, but it's 0 because we don't have anything, didn't assign anything. So if I wanted to, I could, and I'll just be sloppy and just paste it in here. And let me put this underneath because we want to print it out after. Change this guy to my student. And set the postgrads to 2000. And then now, if we run it, we're going to get to 2000 down here now instead of 0. So all I do is set the set postgrads to 2000 for my student instead of leaving it uninitialized. But the purpose of the example originally was to show you that if it's uninitialized, it prints out 0. We have never assigned it to anything. We didn't initialize that at all. We declared it up here, but we never initialized it to anything. So oftentimes I see this. This is stupid and unnecessary because not only is it going to give you an error, but depending upon the situation, why would I want it to be equal to 0 when it's already equal to 0? It's already, it's like a double negative. I mean, it's already initialized to 0. Because people who learned C learned declaration and initialization. If you did this in C, or C++ actually, you said integer this, and you said C out this, or printf this, or whatever, you come out with an error message, or it gives you garbage, comes to the screen. Or maybe the compiler says, hey, you declared it, but you didn't initialize it. So in dynamically allocated languages, it's automatically initialized, which is why it works that way in Java and works that way in Objective-C. So you can declare it, it's automatically initialized. So not a biggie. Yes, I can. You can also see this in the downloaded. And there's nothing in here that initializes. We just have the methods in here. You don't repeat the data.
Like, in this, the print method has total number of students. But when we are doing, when you're typing in main student, it's just giving 2000. It's not taking that print function.
It is in here. We set the number to 120, and then we set the other one, the undergrads to 120, the postgrads to 2000, and the total is this one plus this one. And the print is printing it out. So this one here says 2120. I only set one of them here. I can set the other one. I can see I set postgrads. Let me set undergrads here. I just set one of them. The other one's 0. They're both 0 until I set one of them. These, by the way, are called setters and getters, which we get automatically with property and synthesize, which is another way of automating things, but we'll get into that later. I don't want to hit everything, but In C, C++, Java, we have the same concept of the setters and the getters, or the accessors and the modifiers. So what you do is you have, these are private. You have private data members, and you have public member functions that set and get. We just have setters, we don't have getters. I could write a couple more functions here and say get undergrads and get postgrads. And then if I ran, in the implementation of that, instead of setting it where I'm setting it to this, I'm going to get it, which I'm going to print it out to the screen. So actually here, I'll write one for you so you can see what I'm talking about. Sometimes it's easier or slower when people see it this way. So I'll just write one of the getters, and it's going to return an int because I'm getting an integer value, because these two are both integers. So I'm going to get a function prototype here, and I'm going to say get undergrads. Maybe I should have said postgrads. Undergrads. There we go. Have I spelled that correctly? Undergrads. Okay, so I'm going to do a cheat sheet because I'm a terrible typist. So I put a function prototype in here, and this one is going to return an integer. You can return more than just void. So if I come back over here, these are all void. So this is better. So if I come in here and paste in here, but this time provide the opening and the closing brackets. I have the function now, and why do I have this? Control reaches the end of a non. Yes, I know, because I didn't put return in here. Return. I don't know, some of these error messages, some of these warnings I don't like. So return, what am I going to return? What's it called? Undergrads, so M undergrads. So let's just do this. All right, so now I'm returning M undergrads. So I can actually put this out here. Let's go back to, so now I have this new function here, this new method here that gets the, I could actually put it, in this one here it says total students is equal to this, and then I'm doing an NSLog. I could actually put the call in the NSLog, which is what I'm going to do next. So I'm going to copy this so I don't have to worry about my typing again. I'm going to go to the main method, and now down here at the bottom, I'll put this at the last so we can see what this looks like. Okay, so now I'm going to NSLog to the console, and this is going to be number, let's see, num of undergrads. I'm still returning an integer, but instead I'm going to put the method call in here to run that method I just created, and I'm going to run it on I'm going to run it on iOS student. So let me cut it so I don't have to worry about typing this correctly. And I'm going to run get undergrads, and I'm going to close my bracket there. So now I'm going to run this method, and whatever gets returned, which is going to be an integer value of that data member that I have in there, is going to be substituted in for this I right here. And so my output should say number of undergrads along with that. So let's take a look here. Let's just back up. And number of undergrads is equal to 120, according to my output. This is the line of code that got printed out with this line of code. So the NSLog is nice. If you try to mix the NSLog with, and let me do this here. Let's try and mix and match in the same sentence. Not going to work. We're going to get an error message. So if I do this, and don't use NSLog, but use printf. Let's see, printf. There we go. And I take out this here, and I try to run the same thing. And I don't get an error message. This is kind of weird. It should give me an error message. It used to give me an error message. It doesn't give me an error message anymore. Thank you for getting rid of that error message. So it used to be if you mixed and matched, that would cause a problem. It didn't cause a problem, which is kind of interesting. But keep in mind, this is a brand new version of Xcode, so there's going to be some differences, which will be interesting. The new lines should work. Let's see. Yep, the new lines work too. That's pretty cool. Okay, good. That used to have problems. You had to do an NSLog for it. Because you could change this here, actually. NSLog. And then just put the @ symbol in. So this is kind of an interesting thing. On the first day of programming course, people usually want to know, how do you do I/O? How do you get stuff in? How do you get stuff out? And what's this message going to tell me? An implicit declaration of function NSLog is invalid. Oh, because I spelt it wrong. There we go. How about that? Okay. So now I can see I can do the same thing. I used to have problems running it with this way, but apparently it's working. So here we'll put this one. So anyway, to get system out, or that's the Java version of it, or cout, which is the C++ version of it, or printf, it's NSLog. This is the log console. You can use NSLog in iOS development as well for the iPhone. So. Right, so that's basically an orientation or introduction to the syntax of what we're looking at. Do we have any questions so far? Anyone wants to ask? I'm going to push forward. Let's push forward. All right, so that was the first project. If I go into the Objective-C Code 1 folder that I downloaded, I see I have a simple hello world. And the way you're going to bring these projects up is you're just going to double click on it. And I'm showing you what this is so that when you get home you can actually, or when you get your Mac computers, you can actually run these and know what you're looking at. Hello world is what we did in the DOS. So this one is just the one that says hello world on it. Not that spectacular, not that detail oriented. So don't worry about that one. Example number 1 was the one we just looked at that had student in it. So we just looked at example number 1. That was this one here that we just built. I built it out of a different project. Ours is slightly different, but this is the same code. In here we also have this thing called person initializer. So let's look at initializers for a second. So person initializer has person.h and person.m in it. Let's just load one up here. And let me talk about initializers for a second. So it's the same kind of an example as the student that we just looked at, except for this one is definitely more feature-rich. So you might notice that we have, in fact, why is this, well, it doesn't really matter that it's in 2 separate folders. We could very well put main into here. But you can actually, I know why I did this. I did this to demonstrate the folder structure to you. So let's go back here for a second. You see that we have a main folder. Let's go back to another one, actually. Let me backtrack so I can give you the full picture. So if we look at example 1, what we just looked at, we got the project, and then we got one main folder called example 1. And inside, this is the source code folder, by the way. So if you're familiar with Eclipse, this is the SRC folder, so for source code. Go in here, we got everything in here. What do we got in here? The only files we cared about was main, student H, and student M. These 2 are auto-generated. Don't delete them. Leave them alone. If you do delete them, I believe, actually, let's just try it. I believe they'll be recreated for you the next time you run the project. Let's just test this. Let me empty my trash just to make sure. Well, let's see. They probably will get recreated. Oh, build failed. No, they used to get recreated. They're not getting recreated. So don't delete them. Actually, wait a minute. Let's delete them out of here. Now let's run it. Nah, build failed. They're configuration files. They're project configuration files. You need those. So when you turn an assignment in for me and you want to turn in this one right here, just zip it up. So each one of your projects will be in its own folder. So you just go like this, compress to zip, and you upload that into the EMS. It gives me everything. If you give me just the source code files, I'm going to have the same problem I just had a few minutes ago. I'm not going to have your project file. I'm not going to be able to run it. I can look at your source code. I can double click on your files and look at everything. But I can't really run your project. Neither can you, actually, in the future. Unless you rebuild the project, which is what happened here because I deleted those 2 files. So you see this is the main project folder, and then we have the project configuration, or the starting of the project. When we double click on this, this is what opens up the project in Xcode. Now this other example that we just looked at, I purposely, and this is the one that's called person initializer.
What is the template that you chose for this project?
No template. It's
Empty application.
it is actually, there is a template. It's command line tool. So it's under OSS application. The template is command line tool if you want to build it from scratch. Otherwise, you can download that code, that example 1 file, and double click on it and bring it in. So here we have person initializer folder, and person initializer folder has main in it along with those 2 configuration files. And then I pulled out person.h and person.m and stuck it on the outer folder. So when I load this one up, I've got a subfolder here, person initializer, and it has main in it. And then I have everything else in the outer. Wherever you stick it in here, it ends up in a different location out there in your folder list. So this is going to look to match this. Now if I want to, I could take this guy here, and actually it's better to take these guys here and load them into here. So when you build it, it saves it for you automatically, and I have the habit of building it instead of saving it. If I refresh this folder, I believe I copied them instead of moving them. So now I have them out here, and I don't have them in here. Interesting. If I deleted these, let's see what's going to happen. I can always unzip this thing again. I see that they're in red. So here's what's going to happen to you. You're going to go, oh man, I can't do these assignments on my own. I got to go to the internet and I got to find source code examples. And you download the example and you see it and something looks red in here. If it's red, it means it's missing. I just threw those in the garbage. And they were actually in 2 different locations. So if I had left them, let's put them back actually. Put back. Put back. If I moved them into here, I believe I'm going to have the same problem, but let's just see. Let's just shut the project and open it back up. I got the same problem. They're both red again. So I moved them in here. They didn't move on the disk. They didn't move on the hard disk. I deleted them. Oh, wrong problem. Put them back. So you actually have to put them where Xcode thinks they're supposed to be in order for them to actually be found, which is kind of ironic. I believe that there used to be an import actually as well, so I can open. Let me find the option. What was this called? Student initializer. Is it person.h? Oops, no, there used to be an import. Hold on a second, let me find the option. Well, the better thing is not to move them around. And then if you move them back, what I'm trying to do is get the red to go away. If I move them back, let's see, this guy here, person.h and person.m. We'll stick them right here. Miraculously, the red's gone, and it works again. So if you move stuff around outside of the project, it doesn't sync with the project. Inside of the project, it didn't sync with what was outside of the project either. Long story short, don't move things around. Save things where they're supposed to be and leave them alone. This one should run actually. Okay, good. All right, so let's go back to person. So this is kind of like student, but we have an instance of an object called we have an object definition called person. And did they just turn the heater on in here again? Yeah, the heater's been on for a while. Are you guys too hot yet? Let me know if you get too hot. I'll tell them to turn it down. So, okay, well, I can feel it, the air hitting my face. Huh?
The vent is that way.
Yeah, the vent pushes the hot air into me. Actually, I can feel it. It happened like about maybe 5 minutes ago. All right, so we have a new person here, and it's the same format as before, but it lends itself to a pretty decent learning exercise here. Make this a little bit bigger. Well, here, actually, let's just do this one. Let's do this one. There we go. These navigation points, I forgot to tell you about the navigation. The blue part, this is the same as they had before. It's telling you which part of the screen. It's weird. This is turned off. This is turned on. It turns to blue. I would make it green or something. This is the lower end of the screen. Turn it off. Turn it back on. You can turn it off. This is the left-hand side of the screen. This is the right side. I was trying to make some more real estate, but I like this part up over here, so I just got rid of the right-hand side. One of the things you probably want to do is when you first install your Xcode is to get familiar with the interface. So it's actually not too bad. These guys are going to show us different options within this pane here. Actually, no. This one's going to show us source code editor. It's going to bring up another window for us, which we didn't really want. We wanted to have this window. This is for the 3 different panes that are going to show up here. So this guy is the second pane. So I don't want him. I want this one here, which is going to be my full 1 pane. So I have 1 pane, 2 panes with source code editor, which I'm going to get into later, or just the properties themselves. So I just want the main screen, so I'm putting it up. All right, so we have an @interface person :NSObject, and then integer name, integer age, and then integer height. This is what we saw before, so we got a new thing here. We have an object. This is an NS string asterisk name. So that's equivalent to string name in C++. The reason why this is kind of interesting, everything with an NS is an object. All objects need this asterisk. So you don't have a choice of not using a pointer. C++, you can use a pointer or you could not use a pointer. Objective-C always use a pointer with an object. All objects need pointers. So we have NS string asterisk. So if we leave the asterisk out, we end up with a problem, actually. Well, it's not going to tell me, but further down the road, I'm going to have a problem with this. And then now I can have 3 different initializers here. So I've got, let me just separate the initializers out. This is the interface, which is giving us our header, our .h file. So I have ID as the return type, which makes it generic. And I do have a return type. And the return type of the ID is basically the generic object, which is great to use as an initializer. This is also in the downloaded file. So, okay. Anyway, so with integer with age, which is going to be an integer age. So we're going to have 3 different initializers. One takes just the age. The other one takes the age and the height. And the other one takes the age, the height, and the name. So we have and height, and name as option. These are optional, by the way. So if we want to optionally put a name on the parameter, to use the parameter when we run this initializer in the main program, we know what A, B, and C are. If we just say A, B, and C, I don't know what A, well, I might know what A is, age. Who knows what order we're supposed to put them in? So by putting a name on the parameter list, it's kind of like this in C. If it went like this, went integer, integer, how would you know one was the height and one was the age? You don't know. So instead you go integer A for age and integer H for height, you know, as parameters, which is the same kind of equivalent to putting names on the parameters here. So these are what's called named parameters. So here is just one, integer age. When we run, and I'm going to show you, I'm going to zip over to the main to show you actually. This is the line here. Yes, I know, the expression result is unused. No problem. We run the int, we're just running the basic int. And Bob, integer with age 55 and height 10 and name n name. So we know that this is n height. If we have n height in here, when we go to run it, we put n height over there. So I have one here that doesn't have anything. It's integer with age. So over here, I don't actually have it being used. So person Bob, nothing happens with Bob. Why doesn't anything happen with Bob? Expression results unused. Okay. Well, I have to make a new one.
So you include or you import the file?
Excuse me? You can import or include. So in here I imported it. The last example I included it. So if you include it, the code gets compiled in. If you import it, it gets determined at runtime. Does it really matter to me one way or the other? By theory, you want to import, you don't want to include, because it saves memory. It makes a smaller executable file, makes things more dynamic. Include is a C++ approach to add the code to it. Include all of this stuff in here in my executable file, and my linker is doing that, actually. In Objective-C, do we need to have it all together? Nah, we can wait until the thing runs and then import it in later. So it's doing the same thing, accomplishing the same task, doing it two different ways. Both of them work, and you can use them simultaneously. In the other example, I had import, and then I had include, and I forgot to point that out, actually, so, which is a good thing that you pointed it out, because definitely, yeah, that's, heads up right there. What is that? So. Anyway, so this one was an integer with age. This one here is integer with age. Or excuse me, that one was an integer. I think the one that was actually running is this last one because we set it to Bob. The first item that we created isn't using any of these. So if we did integer with age colon age, we could do this. I'm going to make another object, actually. Let's see, so we got person Bob. Let's do this. Person Mary. Person alloc, that's a given. We're always going to have to alloc it. Integer, let's just do with age. With age. And you can see how it kind of fit it in for me. So I want this one. So then I can put an integer value in here, and let's make her 21. And let's put a semicolon at the end of that line. So then I've got allo, or alloc. My typing is terrible. So now I got Mary. And you might notice that I've got this little thing here, and I got a little line here. I'm just going to say that she's never used. Unused variable Mary, because I didn't do anything with Mary. So I can go and show Mary. So I can go, let's say Mary, show age. And that little line goes away. And then some of you go, well, how come you should put this here? I did that on purpose to show you that, I'm sorry, accidentally I was typing it, but you can have it anywhere you want. It has to show up in between the data type and in between Mary, or the name of the variable. So some people like to do that. It's the same as C++. You can put it integer asterisk I, or you can put integer space asterisk I. It means the same thing. A lot of people like it over here because it's the, it's the reference to this object and not the name of the object that we're going to use over and over again. So I don't know, it's your choice. Either way, it works just fine. So this is running the integer with age 21, and over here I have this method here. This is the prototype of the method called integer with age. And notice this other one that was being used isn't using anything at all. It's just int. So as long as the word init is in the method name, it's now an initializer. And you use it as an initializer. You explicitly call which initializer you want to use. If you're talking C++, these are 3 different constructors. We don't have constructors, we have initializers. And in the constructor, you just call the constructor in C++. It just picks whatever one matches the method, the method parameter list that you have. In Objective-C, you actually have to say, I want to use this one, I want to use that one, I want to use that one. Only difference between this one and these other ones is that this one takes on 1, and then we have n height, colon. So I could take out the n height if I want, and just leave it like that. If I do that, then I don't have to put n height in there when I call it. But how do I know I'm doing n height and name? So let me put this back. If I put that back and come over here, I did that because of this. So integer with age. Didn't I show Bob? Why has Bob got a message here? Oh well. I got Bob. Oh, because I initialized him and then I initialized him again. So I initialized him twice. So we can leave Bob alone here, actually, and we can just do this. We can say, yeah, that's okay. That's why this message is going on. So, long story short, Bob got initialized twice. Can you do that in C++? No. You can do that here because you're explicitly calling the initializer. So later on, you got a piece of message, you can just run the initializer again, but you don't want to. It's better practice to run the setters and the getters at that point, past the initial creation of the object. So when you create the object, you allocate it, you initialize it, then you're done with it, and then you're going to use it. So the setters and getters get used normally to set the data properties at that point. Here, however, I kind of just did this to show you that you can run it again, no problem. We already ran it once.
Using pointers, right?
Huh?
Because we are using pointers.
Yeah, because you're using pointers. You're going out to the memory location. Let me just show you what's going on here. Person Bob, that's an initializer. I already got initialized. So if that's the case, then what do we have down here? Bob with init with age 55. We're calling the method all over again on it. But Bob's a reference. So if we're going to do that down there, we don't actually have to do that. We could take that out of there. And now Bob's not being, whoops, we got two sets of brackets we don't need anymore. So now, here we go. And we could put Bob up here if we wanted to make this a little bit more organized. And we're still going to get a strange, what is this one going to say? Expression result unused. All right, well, whatever. The better format would be doing this, actually. Let's put him together. If we're going to initialize him, I'm just going to cut and paste this, actually. Well, actually, I'm going to cut and paste the whole line this way. Get rid of Bob here. There we go. Now we took away all the problems because now we're not running the initializer more than once. We're only running it one time. And if we want to run this one, we might as well run this one. So we can stream in the multiples. This is running the default initializer on my person, showing my person's age, which is going to be nothing. This one here is going to create Bob, and then Bob is, he's going to be 55, and the height is 10, and the name is Bob. So then Mary, oh, we didn't show Bob. Oh, here's show age. Bob show age. So let's move this up here. And then we can show Bob's age. And then we got Mary under here. And Mary's also a person. She's going to be initialized to 21. We're going to show Mary. So when we run this thing, what we get is all of the ages shown. So we're actually, what is wrong here? We have an interesting issue. We have memory-related issues. Interesting. Now let's go back up here. Probably because I moved all those files around. Let's do something else. The other problem is when you move those files around. I'm going to throw away this code and recreate it. Don't worry, all the changes we made doesn't really matter. Now I'm going to run it, and we're going to have the same problem. Interesting. What is this problem here? Signal. Well, it certainly didn't like that initialization I did twice. So, all right, so let me just show, for those people who weren't watching, let me show you what happened, and this is how you get out of the situation. So, right now it's running, and it's running just fine. Let me clear the clear the real estate out a little bit. And this went away. When I get an error message, it goes away. So let me reduplicate what I just did so I can show you what happened. So the newer version doesn't like the fact that I've initialized them twice. Or there was something it didn't like about the project that I had up there before. In fact, I didn't try this. I probably could have commented out the code, probably would have fixed it. When I run it, I'm clicking this little arrow on the left-hand side of the screen, and now it's going to work. Now it's going to build just fine. All right, what I wanted to do, I wanted it to make an error that time. When it does make an error, this goes away. Maybe I can introduce an error. No. Okay, so now it's working just fine. A few minutes ago, it wasn't working. It's a little quirky. So if you close down Xcode, load it back up again, sometimes it's the file placement, the moving of the placement. There's a little bit of memory that gets stored in here, and the memory doesn't always refresh itself in real time. It's like cached memory in terms of the project state. So there's a product, under product clean, it is still there. You can actually clean the build. Maybe if I run it again, it'll actually trigger the error. Yep, it triggered, no, build successful, bummer. I was waiting for that error to come back. Long story short, if you hadn't noticed what ended up happening over here is it'll show you the error messages. It used to show you, and it still shows you up here, that there's 4 warnings. If I click on the warnings, it used to show it. It's not going to show me. Okay. If the build fails, the build is still running. There's a little box here that turns black. If you click on the box, it stops it, which is what I was doing, and then I ran it again. If this goes away, it's because this screen here has changed perspective to one of the other buttons up here. So one of them here is the warnings, actually. I can manually put it back on here. And this one says the valid project settings need to be updated. So if I update, perform the change, would you like to Xcode to take automatic snapshots before project clean? Oh, sure, why not? Enable it. I fixed the build settings on this, which was one of the problems. This is an older project type. You're going to run into the same situation, because every one of my examples is going to be prior to this Xcode version, because this Xcode version just came out today. So long story short, until I get everything updated. Huh?
It's showing 21 page for Mary. But in the code you just deleted.
I know, I deleted it and then I put it back. It's back. If I want to see the source code again, I click on this little folder on the left-hand side. And if I click over here, let's go back to the main method here. I took Mary out.
Yeah.
Because I was playing around with it because it wouldn't compile. I deleted it.
When you run it, it's coming.
Do you see Mary in here?
Because age for Mary was 21.
Oh, that's probably because the memory hasn't been updated correctly, as I was mentioning before. It's cached, which is why it shouldn't be showing 21. That's interesting. The age is 21. It is showing Mary's. Let's clear this bottom screen, actually. Let's clean the product. Here, let's clean it. Let's build it manually. Now let's run it. Age is 21. And I don't have age of 21 at all in here. Nice. So let's see. Let me close Xcode completely. And then load Xcode back up. Actually, let's load this project back up here. It shouldn't be showing anything 21. Nothing 21 in the source code. So let's see. Just want to make sure I don't have anything extra saved in here. I don't. The age is 21. Hold on one second. Let me just see real quick. My person might be 21. Yes. Let me finish with the example. It's actually printing out 2. So now that I've refreshed my memory on this example, we have the default initializer was not in here, but we have it by default. So we have an init with no parameters at all. So in the implementation, which I haven't gotten to yet, so the .m file here has got 2 implementations on it. And what we've got here is the default initializer. Then we have the implementation for the other initializers that I just created. And in the main program, the reason why it says 21 on there is because my person was created, and my person show age is giving us our 21. So we could do this and go like, NSLog. Oh, let's just do my person. So we know which one is coming out. So when we run it, build failed. Implicit declaration of NSLog. Oh, probably because I misspelled it. This is capital. It should be lowercase. There we go. And so now it says my person, colon, person initializer, age is 21. And here I probably have something that says person initializer. It's getting printed out. And let's say what we got here. Nope, this is the debug code. This is person initializer is printing out the age is 21.
Show age.
The show method. So let's see. The show method is printing that out a bit. The age is 21. The age. So this method here, the show method, is printing out the NSLog with the age is, which is showing up here. This is just the debugger telling me that it's the initializer that's inside a person that's running, that initially ran. So this piece of code ran first, this piece of code ran second, this piece of code ran third. So it's showing you line by line from the NSLog for the console output. That's a better way. So the output that we're getting is my person colon, that's the NSLog I put in. The age is 21, the age is 55. So, which is the NSLog that I put in, and then the show age, which is printing stuff out.
What happens if you try to print the object itself using NSLog?
And we'll show you. Let's just print it out right here. Actually, let's just take my person out. And what do you want me to put in here? My person?
Yep.
I believe it's going to tell me that is a format string is not a string literal, potentially insecure.
You can try to specify the format.
Whoa. This is what I wanted. All right, so I got to this point. I was waiting for this to happen. And most people, when we introduced an error, by the way. So when we introduced the error by printing out an object through a signal, so then I get all this code that gets printed out down here. And then people go through in here and I try to read the code. This reads like Greek. I wouldn't bother with this code down here. And then they come over here, and I actually try to do this over here. I try to look over here and I can go NSLog. And what I try to look for is the keywords over here. We made a problem with NSLog. We put an object in there instead of a string. NSLog takes a string parameter. We would have to cast that object to a string, and if we did, we're going to get the memory address. Same thing that we would get in C++. If we printed out the pointer, we're going to get the memory address. But I didn't give it a string. I gave it a potentially unsafe thing, which it didn't know what it was, and it was an object reference. So the object reference is the memory address of where the object is located in memory. Same thing as we get in C++. It's a pointer. So long story short, I can convert that to a string. And if I do, I'm going to get the memory address. Why do I want that? But we can do it. And long story short, the only thing that's going to give me any hint over here is this NSLog on line 17. And I'm going to go, oh, this reads like Greek. All this stuff reads like Greek. Now, this actually is black. I just clicked on it and made it, actually run it again. You see what I'm talking about. Build succeeded. Does that look like it was very successful to you? Doesn't. It was succeeding, but it didn't know what to do with it. So it compiled, it built, but it can't run it because it doesn't know what to do with that object because it was expecting a string. This is hard to tell in this new interface, but this is black. And the program is still running. So the other biggest mistake is students say, oh, okay, let's just go back here. We're running. We're still running. And then you're going to have like 5 different, and it's not going to work until you stop running. And then you're going to run out of memory eventually because you're going to have 5 or 6 different versions of this thing running. So next to it, click on this little square then it turns light in color, and now it's not running anymore. Takes it out of memory, cleans it up. And then what ends up happening is I usually come over here and I'll go into product and I'll go clean at this point. Clean it all up. And then I'll try and fix my problem. This is my offending code right here. So I'll just kind of highlight that like that. And comment that out. And then I'll run it and I'll see everything works just fine now. So when you build fails, you fix something, clean the project, it just cleans out the temporary memory, runs it again. Otherwise, what ended up happening is I just accidentally did it earlier, where it just, the cache, the program was good, but the cache wasn't up to date. So it's going to fail after fail after fail, even though the code is correct. It's going to keep failing on you. It's the worst. They haven't fixed this yet, actually. This is from the old system, from the previous version, so it's still here in the newer version, which is actually kind of interesting. So, all right, so back to the code here. So now that I'm on this window, I'm by file type. Now I'll leave it on by file. You click on the little folder, and it's the smallest icon in the world. You click on it over here, and it opens up the folder view for you again. So if I go back in here and look at the implementation, I have a couple of different things, and let's just leave you alone. So in the init, it's actually going to return, and the reason why we have the ID in here is because this is going to return a person. If we put this in a student, it'll return a student. Do we really want to put this person in here? It's easier just for reusability to put ID in there. So it could be an object, a person, a cat, a dog. It could be anything we want. So it's kind of a generic object placement. So init returns an ID, generic object. Self is equal to, so now we got a self. We have super, and we have self. Super, in our case, is NS object, because we're inheriting from NS objects. If you look at this super right here. So later on, we'll be writing code that we have one class that inherits from another class, and we just change this and we put student in here or something. We'll get to that probably tomorrow. But for right now, just know that this is where we're inheriting from. This is super, this is self, which is like this. Java does this. This dot something. Super, C++ does, no, Java does super. Super back, so it goes super from one constructor to another constructor. Here we're not constructor overloading, we're initializer overloading. So in the initializer, we're doing super init. So, and it's going to be super init's returning self. So we're explicitly saying super initialize yourself. Why do we have to do that? And it's just, I think it's kind of tedious. But perhaps maybe in this new version, I don't know, I should try taking it out and seeing if it works. I would think it would automatically initialize, but who knows. So super init, we could go self init if we wanted to, initialize ourselves. We would run our init function method. So self is equal to super init, give us a super. If self, if we got a self, we didn't fail, which means the only reason why this would fail is if we ran out of memory and we couldn't create another object in the system. Then initialize everything. Age is equal to 21, name is equal to, here we'll set the name to Mary, I don't know. Name is equal to something, height is equal to 0. Do we really have to set the height to 0? Probably not. It's going to be set automatically for us. So we don't even have to set the name to empty either. But that's kind of, where you'd put the initialization in there. And then you're returning self. And self is a generic ID type. So if you take that, cut and paste it, use it in everything you want to overload an initializer, you got generic code that you can reuse all over the place. All your default initializers are going to look like that. This one here is going to look a little different. We're going to do if self is equal to super init, which means we got a NS object, which is the same piece of code as up here, but we put it together. So we have self is equal to super init, and then we have, instead of doing self is equal to super init, if self, we're just going to put if self is equal to super init. This is common, more common than this because it's one line of code versus two. And we're just going to set the age is equal to what? Did we come in here? The age. Age is equal to the age. Here is the age, the height, the name that came through. Same thing you get with C++ when you pass parameters in with a method. So you have to be familiar with functions, function calls, in order to understand that, but we're still using the same. So over here we have this method prototype with age and height and name, an example in here. So in the .m implementation, this is the same line as the function prototype, but we added the names that we're going to use inside. So we're going to take this parameter in and we're going to use it as the name. So if you look over here, we don't see the name. So we put a name on it so that we can use it inside the method body. So here we see, just to refresh your memory. Actually, let's just take a look at this one here. We have and height. So we have age and height. And then over here, here's the one here, and height. So we have the height, the age. So this implementation added another item to the method, which is the name of the parameters. So we named the parameters in the implementation, and in the prototype we just said this is going to be an integer, and that one's going to be another integer, and that one's going to be another integer. And we're going to name the integer prototype and height. We're going to name inside of the method implementation, we're going to call it the height. You don't have to use the or and or anything like that. These are just generic names I put together for this example. But just know that in order to use the parameters you're passing into the method inside of the method, you have to put a name on them and then refer to them by their name inside of the method. So here where all these things we're always going to return, and it always returns an instance of the object. So on the basic one here, we have return self. On this one here, return self. This one here, return. And then instead of just putting self and then putting all the code above it, like these two, I put it all on one line. So it says self, in it with age, the age and height, the height and name, something. So I'm calling an initializer from an initializer. So just like I did in main, where I called the initializer after the initializer was already being run, if I want to, save myself some time and not have to reinvent the wheel, I could take the little one, first parameter one, second parameter one, third parameter one, use on the third parameter one, call the first one and the second one. Because I'm just going to set all three of them, right? And then set the name and name to something if I'm not going to set the name. So this is the second one. It takes the age and the height, and it's running the age, height, and name initializer, but setting the name to something. And then we have the age, which is just going to set the age and the height to 0, but it's going to set the age to something. So you don't have to do it this way. You could do it this way if you want. You can set them individually, or you can run in the initializer from the initializer, which is how this is working actually. And then the show age is what we saw before, is the NSLog. It's going to show everything. And basically, it's just going to show the age. We can create another one that says set age, show age, and then we can set height, show height, if we wanted to. I didn't put any setters and getters in here. I just put the, basically put the initializers in this example. So this one is called person initializer inside of the code. Before I move on, this is a good segment to take a break actually before I move on to the next concept. So I'm going to stop this part of the video.